In this session, we will demo spanning tree protocol workings and fine-tuning based on the previous session we had. So what we will cover in this session is where is the root bridge. So we have our switch 1, 2, 3 and 4 where we will find out where is the root bridge. That will be the first thing. And then we will try to influence the root bridge location. So we will configure the root bridge manually. We will also take a look at the path cost method, long and short, and see how that reflects in the show spanning tree command. And then we will influence the port state mostly on these two links here. And we will finish off by looking at rapid per VLAN spanning tree configuration. So I'll simply start by looking at all my 4 switches and run my show spanning tree command. And what I'm looking for here is the switch which is established as the root bridge. So on switch 2 I can see that this bridge is the root. So switch 2 is the root bridge. What I would like to do is to actually move the root bridge to switch 1. So I hop into my switch 1 and start my configuration. So spanning tree, and I have to select either a single VLAN for which I want switch 1 to be the root bridge or range of VLANs. But let's do it from VLAN 1 to 100, for example. And I'll set this switch as a root bridge, and I want it to be the primary root bridge. I won't be using the diameter command, so I will just enter. Remember, switch 2 was the root before we made these changes. And our priority was 32769, which is basically 32768 plus 1 for the VLAN ID. In this case is VLAN 1. So let's check what's happening on switch 1. So I can see that switch 1 has become the root. And the priority has changed. So because we have, instead of setting the priority via the configuration by setting switch 1 as the root bridge, the priority has been amended to be lower and better than switch 2. So now we have changed switch 1 to be the root bridge. The next point is the path cost method. Because our ports are all gigabit speed, the cost per port is 4. So let's try to change this by using the longest method, or the long method. Spanning tree, path cost method, and here you have 2 options. So let's use the long option. And this is useful if you want to have more granularity on your port when you are deploying 100 gig ports, for example. So if I run my same command as before, the show spanning tree command, you can see that the cost has now changed to 20,000 because we're using the long method. Let's revert back to the short, and you can see that now we're back to using a cost of 4, which is the old method used to allocate cost per port speed. So the next task is to look at how to influence the port states. Between switch 1 and switch 3, we have some sort of loop because we have 2 links connecting these 2 switches. We have our root as switch 1. This would be my designated port and a designated port. One of these 2 ports on switch 3, either gigabit 01 or 02, would be the root port, and the other one will be in blocking mode. So based on what we have discussed in the previous session, the tiebreaker will be the lowest port ID. So in theory, is gigabit 02 that should be the root port. Gigabit 01 would be on blocking mode. So let's validate this. So if I go to switch 3, so the root port is gigabit 02, whereas gigabit 01 is in blocking mode, which is exactly what we expected. So now, how do we influence this to make a change? So say, for example, you have some issues with this link. You're dropping packets, or you have some issues with your fiber and so forth, and you prefer to move your root port to gigabit 01, but you don't want to shut down gigabit 02. Obviously, it's easier if you just went ahead and shut down gigabit 02, then you only have a single link, and gigabit 01 will move from being in blocking mode to forwarding mode, because it will become the only RP. So there are two ways we can do this. We can either do it on switch 3 by playing with the cost on these two ports. So if we were to increase the cost on gigabit 02, gigabit 01 will have a lower cost to reach switch 1, and therefore will become the root port. But the issue here is that the cost, once you change the cost on these ports, the cost will actually affect all the other switches. It will affect the whole path. So I don't want to change the cost at this point. Let's look at what can be done on switch 1. So trying to find a method that is locally significant to switch 1 only and has no impact on the remaining switches. So one of the methods is to actually improve the priority of gigabit 02 or worsen the priority of gigabit 01. So let's look at the priority on this port. So these ports have the same default priority of 128. So looking at gigabit 02, let's improve this. So I'll go into my config mode once more. And I'll change the priority here. And I would like to use 96. So let's quickly hop back to switch 3 and see what's happening. I can see that gigabit 01 now has transitioned to listening mode. It was blocking before, now it's listening. And the next phase should be learning. So now the port is learning. And notice that both ports are in blocking mode. So at the moment, none of the ports are forwarding frames. So now gigabit 01 is the one which is in forwarding mode, whereas gigabit 02 is in blocking mode. So we have managed to actually influence the root port position or the root port assignment on switch 3 by tuning the priorities on switch 1. The next thing is Portfast. So I will assume I have an interface gigabit 03, spanning tree, Portfast. As simple as this. Here you obviously receive a warning to ensure that you know what you're doing. So you will never, or you shall never, so you should only have Portfast enabled on a port that is connected to an end host device, not a switch. Else you're opening yourself to having loops. But looking earlier at switch 3, how it transitioned from blocking mode to forwarding mode, it should take about 50 seconds for this to happen, which, as discussed, is really long by today's standards. So another way of improving this is to configure rapid spanning tree. So the configuration is actually straightforward. And let's do a quick test. If you look at your root port on switch 3 is still gigabit 01. Let's go back to switch 1 and remove the priority and see how quickly it will reconverge to the initial state we had earlier. So I'll remove my priority and hop back into switch 3. Straight away gigabit 02 goes into forwarding state. So we have reached the end of our quick session. I hope you have found it informative and thank you for watching.